Welcome to The Explainer. I'm absolutely thrilled to have you here today because we're tackling something incredibly cool. We're not just talking theory here, we're breaking down the exact architecture of a fully autonomous AI scheduling agent. If you've ever pulled your hair out over the endless back and forth of booking an appointment, you're gonna love this. We'll see exactly how an AI goes from a simple prompt to actually executing real-world business tasks. So how do you build an AI that checks calendars, writes emails, and actually makes phone calls? I know, it sounds a bit like magic, right? But it's actually just brilliant engineering. We're looking at solving that very real, honestly very tedious problem of manual clinic scheduling. Just imagine an AI that doesn't just chat, but literally looks at a Google Calendar, spots an open slot, books it, emails the staff, and then picks up the phone to call the patient to confirm. That's exactly what we're tearing down today.
Okay, let's dive into this. Here's our roadmap for today. First, we'll meet the AI receptionist, then look at the user booking journey, check out the developer tech stack, dive into LangGraph and tool routing, and finally, take it from prototype to local.
Starting with Section 1, Meet the AI Receptionist. This is all inspired by real-world tech.
So our inspiration for this comes from a 2024 startup called Arnie, which essentially functions as a super intelligent digital receptionist tailored specifically for dentists. This is an AI agent that handles phone calls, books appointments, checks CRM availability. It literally acts exactly like a human assistant. And you have to remember, this is fundamentally way more than just a chatbot. A chatbot just talks, right? But this system is designed to execute physical business tasks. It takes your preference, like say a 4 p.m. slot on a Friday, and maps it to reality by checking the actual clinic database and making it happen.
Moving on to Section 2, the user booking journey. This is where we map the logic before the code. Now, what's really interesting here is that before writing a single line of code, developers have to define the business flow. Let's walk through those exact steps. Step 1, the user requests an appointment. Step 2, the agent jumps into Google Calendar to check availability. And hey, if 4 p.m. is booked, it'll find an alternative, like 4:30. Then, Step 3, the agent books the slot and drafts a Gmail confirmation. Notice I said drafts there, it doesn't send it directly. Why? Well, during testing, you definitely want human verification. You want the clinic's admin team to review that draft and physically hit send just to be safe. And finally, Step 4, a system called Bland AI makes an outbound phone call to the user to confirm all the details verbally.
All right, Section 3, the developer tech stack. Let's look at the tools powering the workflow.
Here's the specific tech stack we're working with. We're using LangGraph to build the core agent workflow and manage the conversation state. And it's actually worth noting that they recently updated to use functional APIs and decorators, which makes building these workflows even smoother. Now for integrations, connecting the AI to the outside world, we're using a library called Composio. The brain of the whole operation, the LLM, is Gemini 2.0 Flash, which is just fantastic for tool calling, though you could easily swap in OpenAI. And lastly, for those outbound confirmation calls, we're integrating the Bland.com API. Each one of these pieces plays a highly specific and totally crucial role.
I want to highlight a really massive number here, 250. That is the number of integrations Composio offers right out of the box. Think about it. Building custom API integrations for a Google Calendar and Gmail from scratch, that can literally take days of manual setup and debugging. But by leveraging Composio, developers skip all that boilerplate code and plug the AI directly into these services securely in just a matter of minutes. It's a huge time saver.
Which brings us to Section 4, LangGraph and tool routing, or as I like to think of it, protecting the calendar.
This is really the technical climax of the explainer, how we securely route the AI's actions. We are strictly separating read tools from write tools. Checking available slots, that's a read action. Creating an event or drafting an email, that's a write action. There's a fundamental difference between an AI simply looking at data and an AI actually mutating or changing that data.
The whole why behind this separation is to prevent catastrophic AI errors like, no joke, deleting all client appointments. I mean, think about it. If your LLM hallucinates or just gets a bit confused, you absolutely do not want a write access tool accidentally wiping out 30 days of schedule data. By separating these tools, we put a really strict boundary around what the AI can actually change.
So let's break down this specific node structure. We start with the agent node, which is built on a React agent architecture. When the agent decides it needs to use a tool, it hits the tool condition. You can think of this like a smart router. If a user just asks, hey, what times are open? The router sends the workflow to the Find Slots node, which is strictly read-only execution. But if the user says, book me for 4 p.m., the router directs it over to the Tools node, which handles the write-only execution, stuff like creating the calendar event or drafting the email. It's an incredibly elegant and highly secure flow.
Before we move on from the architecture, I absolutely have to share this pro tip directly from the source developers. Always pass the current date, time, and UTC time zone right into your system prompt. Why? Well, LLMs are inherently static. They don't have a built-in internal clock to know what today is. In fact, the developers ran into a hilarious bug where they asked the agent to book an appointment, and because they forgot to inject today's date, the agent cheerfully tried to book a slot back in 2023. So yeah, always ground your agent in current reality.
All right, final stretch. Section 5. From prototype to local. Bringing the agent home.
Here's how you actually build this out. You start your progression in minutes, running quick prototypes in a Google Colab notebook just to test your API keys and basic tool calls. Then, over a few hours, you scaffold out a proper React agent template in your codebase. Over the next few days, you're refining it in an IDE like VS Code or Cursor, configuring your local environment variables, your .env files, to keep those keys locked down and secure. And finally, launch time. By using Docker, developers can seamlessly spin this up and test the agent locally using LangGraph Studio on port 8123. This gives you a gorgeous visual interface where you can literally watch your agent's thought process node by node before you ever push it to production.
We have covered a massive amount of ground in this explainer today, from user journeys to conditional routing inside LangGraph. But I want to leave you with one final provocative question. If this exact LangGraph architecture can flawlessly run a dentist schedule, checking calendars, drafting emails, making phone calls, what other physical businesses could it automate? Salons? Auto repair shops? Consulting firms? The architecture is there. The tools are there. It is just waiting for you to build it. Thank you so much for joining me today, and I seriously can't wait to see what you create.